So we're calculating the total resistance of the following circuit. So what is the resistors in? They are in series. So when they're in series, what do we do? So the total is, this is the working out you should have shown. R1 plus R2 is the total. 6 ohms plus 3 ohms is, everyone? 9 ohms. Now you should have written this rule down. Give yourself a tick if you wrote the rule. We're doing total, total, total. So we're trying to find I, so we can rearrange. I is V divided by R, right? 12 divided by 9. Very good. And what's current in? Amps. Okay. What are the resistors in now? They're parallel resistors. Try not to fall asleep. So, parallel resistors, what does it mean? What's the same everywhere? Voltage is the same everywhere. So everywhere the voltage is 6 volts, right? So we can use this formula to figure out each of the current. So we got 6. Let's look at R1. R1 is 8. So the current through resistor 1 is 6 over 8 amps. So that's number 1. So this is all question 1 so far. Okay, now let's look at R2. What's the voltage for R2? 6. What's the resistance? 4. 6 over 4 is? So that's the resistance. That is the current for R2. Question 2. Total resistance in the circuit. If they're in parallel, how do we find the total resistance? So we have to use the fraction thing. 1 over RT equals 1 over R1 plus 1 over R2. We substitute in the resistance for R1, R2. We got 8 for R1, 4 for R2. What could we make? What could we do with the fractions? Any ideas? Times the 1/4 by 2 on the top and bottom. Is that what everybody did? So you end up with 1 over 8 plus 2 over 8, which is the same as 3 over 8, adding the top numbers together. You got that? Now this is equal to 1 over RT, so we've got one fraction on each side so we can flip both fractions. Everyone comfortable with that? What's 8 over 3 simplified? So rounding. Okay, so that's question 2. Now, what does that mean? This might help you. Have a look at the circuit. Everybody, eyes up here. Have a look at that circuit, right? We have found the total resistance. So this is the same as redrawing this. Now we've got 6 volts and 1 resistor like that. 2.67 ohms. Okay? That's what's happened. We've combined the 2 resistors into 1 resistor. Does that make sense? I don't know if that helps you. So the last question, what is the current leaving the power supply? So now we're just looking at this situation. V equals IR again, substituting in 6, substituting in the 2.67 to get your I.